Hello and Assalamualaikum. My name is Ahmad Naufal, and today I will be presenting about my mini project which entitled Image Restoration of Old Photo. So, contents in this presentation will consist of introduction, methodology, result, analysis and discussion, and lastly conclusion of this project. So for the introduction, generally main causes of degradation are blur, noise, and motion. So restoration of the image is a very big challenge in the field of image processing. So to restore the image, they must have a knowledge of degradation. So the objectives of this mini project is main objective is to restore the old photo, and then in order to restore the old photo, we have to remove the noise from the old photo first. And if the photo is blurry, we will deblur, so it will ease the process of restoring the old photo. Next is the problem statement of this project. So why we choose this topic for this project is because to develop a system that can restore all image to recall some memories. It is also cheaper and efficient in restoring the photo because we can easily save in our devices or computer. Next is the concept chosen. For our project, first we need to differentiate between image restoration and image enhancement. Image restoration is different from image enhancement, as restoration is more objective and enhancement is subjective. Image enhancement could not precisely represent by mathematical function, whereas in image restoration is related to feature extraction from the imperfect image. So next is the classification of restoration technique used in this project: median filter and Wiener filter. Next, I will explain the flow of this project. So the first, user will have to input the image of the old photo. Then the system will ask the user whether the image is blurry or not. If the image is blurry, the system will deblur the image. If not, it will continue the process, which will then ask the user which type of filter that the user wants to use. Next, there are two, as I said earlier, there are two type of classification of restoration technique used in this project, which is median filtering and adaptive filtering. So after user choose the type of filtering, the image will undergo the process of noise removal based on the input intensity that the user input, and then both process will produce the output restored image. Next, I will pass to the next presenter, which is Abdul Haziq.
Thank you, Mr. Naufal. Now, my name is Abdul Aziz and I will be explaining about the result with coding of the system. So, first of all, this line here is to allow the user to choose whatever photo that they want, and then this line right here is to convert the image that the user has chosen into a grayscale, which is black and white. And this whole right here is just a prompt, like a user interface, to ask the user whether the image is blurry or not, and the user can input the answer 1 if yes and 2 if no. If the user choose 1 or yes, the system will deblur the image using Wiener deconvolution. And if the user press 2, meaning no, then the system will not do anything to the picture. And if the user input other than 1 and 2, the system will display wrong input and end the system. Another prompt will be given to the user to ask them for the type of noise removal that they want on their picture. So the user can choose 1 for median filtering, which is better for grain type noises, or 2 for adaptive filtering for better which is better for Gaussian type noises. So the user can input either 1 or 2, and if they input 1, the system will also ask the intensity or size of the filter, which is they can choose any number, but the most optimum number is ranging from 1 to 10. So if the user, for example, insert 5, then the value 5 will be inserted into the parameter of the median filter. Also the same for if y equal to 2, meaning if they choose adaptive filtering, it will also ask for the intensity or size of the filter, and whatever they input, for example 6, the number 6 will be inserted inside the parameter of the winner 2 for adaptive filtering. And if the user choose other than 1 or 2, the system will display wrong input and end the system. So if the user have do everything correctly, then the system will provide an output, which is it will compare between the old photo, which is the original photo, and the old photo after the image has been restored. This is an example of the output if the image is not blurry and have Gaussian type noises. So over here is the user interface. It will ask the user whether if the image is blurry. So for this example, I choose 2 because the image is not blurry. So then the system will ask the type of noise removal that I want, and since this picture is that have a Gaussian type noise, I choose 2 again for adaptive filtering, which is better for Gaussian noise, and the intensity or size of the noise removal that I choose is 5, and the result is here. The left picture is the original photo, and secondly is the photo that has been restored. For analysis and discussion, I will be explaining on how did we determine the optimal range of number for the filter size or intensity. So as you can see from the left graph here, what we're trying to find is the filter size or intensity needed to restore image with different noise density. So as you can see, in the beginning, when the noise density increase, the filter intensity also increase, but little by little. But when the noise density get too high, the filter intensity need to go to jump to a higher number. We also found out that when the filter intensity goes above the value of 10, the restored image will become so distorted that it cannot be considered restoration. That's why we determine that the most optimum range of number is between 1 to 10 to get the most the most desirable result. Also the same for the adaptive filter on the right graph. For the advantages of the system is that it can restore image that is both blurry and noisy. And also this system does not use much computational power, meaning that you will get the result fast and no need to wait for too long. For the disadvantages of the system is that the output image is always in grayscale format, meaning that even if you put colored image, the resulting output will always be in black and white. And another disadvantage is that you need to manually try and error to get the desirable result, meaning the intensity or the size of the filter you must figure it yourself because the system will not automatically detect it for you. In conclusion, this system can restore any image as long as there is not too much noise within the original image, because if there's too much noise and you use a higher filter size or intensity, the resulting image will become so distorted that it cannot be said that any restoration has been done on the image itself. Thank you.